Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. Today we're joined by Omron to talk about some rather interesting stuff to do with the future of smart agriculture and smart cities. Now, without further ado, please tell the audience who you are, what you do, and what you like to do in your free time.
Hi, Robin. Thank you very much for having me. My name is Cary Horan. I am a business development manager at Omron. Basically, what that means is I work with several different focus industries with different products that Omron offers to better incorporate them into various different applications. My focus is generally on the sensing applications, working a lot with our weather sensor as well as some of our optical sensors and visual sensors, things like that. And in my spare time, I do a lot of work with plants, as you can kind of see behind me. I do a lot of different gardening, house plants, and I also do a lot of cooking and baking in my free time.
Oh wow, a man with a green thumb in the food electronics, which kind of makes sense when you're talking about PCBs. So, today we're going to be talking about smart agriculture and smart cities. So what I'd really like to ask you is, how is Omron in this field and what's actually going on?
Yeah, absolutely. Omron has been working on the component side for many, many years. Primarily, our product line has been consisting of power relays, switches, and connectors. Relatively speaking, for Omron's history, sensors has been fairly recent as far as integration of our product line. However, we've had sensors as part of our product line for the past 25 or so years. But as we've been working with sensing devices, we've seen a real rise in how people are looking to gather data and connect that data. And that's never been more evident than in smart city applications. With high population urban areas, there's a lot of information to gather. There's a lot of information that citizens need. And so us as a company being able to offer these solutions that are able to gather key data and not only collect it cleanly and accurately, but also be able to find ways to integrate them into systems, send that data over different communication protocols. Working within smart city applications was sort of a no-brainer as we've expanded our sensor profile.
So in terms of like the newness of this sort of division and the sort of the move into sensors, how new are we talking? 5, 10, 15 years?
Oh, more than that. I mean, I say relatively speaking. I mean, Omron has been in the manufacturing business for, we're coming up on 100 years in a few years. But our sensing division within our device and module solutions, we've been working with a lot of our products for about 25 plus years. I think one of our products we have as our body detection solution that we've been working on for safety and crosswalk applications. We've been installing that software. I think the early iterations of that has been in digital cameras in the late 90s, early 2000s.
So when you say it's new, what we're really saying is this new idea of pushing it into these other industries like smart cities and smart agriculture.
Correct.
That's the new side. But in terms of the sensors and their history, they've been around for donkey's years at this point. So.
Oh yeah. Our sensors have been integrated into a lot of industrial solutions, a lot of commercial solutions. I said digital cameras, home appliances, in the industrial side, power distribution panels, that sort of thing. So we've had our sensors integrated in many different devices and products that people are using every day. But getting into these smart city applications and these fully integrated solutions, that's something that's been fairly recent for us.
And what do you think is like the motivation for trying to get into these industries as they emerge?
I think the real challenging part with a lot of our sensor integration is really these are in a lot of instances newer solutions. This isn't taking an existing product that has a power relay, a switch, a connector, and we need something better. This is adding an entirely new feature to some of these products. So one product that one area that we work with a lot is in smart lighting. We have street lights that are dotting the streets all over the place, urban areas, rural areas, suburban areas. But streetlights are everywhere for safety. I mean, we see them all the time, and it was a very natural progression for people to integrate different sensors in there, such as climate sensing devices, traffic sensing solutions, that sort of thing. We have these streetlights that are already integrated onto the power grid. The structure's already there. It's just adding this new component. But the difference is that it isn't something that is necessarily just going to be plug and play. This is a full revitalization or reconstruction of the existing part or the existing device. So there is a little bit of a challenge in the scope of what it is to get sensing devices integrated rather than mechanical or electrical devices just already incorporated in that are serving that function. But it is an interesting challenge, and we're seeing more and more companies willing to tackle that challenge, and we're happy to be there to offer a solution for them.
Is the focus for this new sort of division towards the higher power side? So we're not talking low power, IoT, low energy sensors. We're talking more like infrastructure, mainstream, sort of bigger devices, if that makes sense.
Well, the device itself, it is bigger in the sense that it is doing a lot more. I mean, one of the sensor that we're really focusing on right now, and we're excited to release our weather sensor that has the all-in-one different sensing devices. It isn't necessarily working with, working in streetlights, of course, very high scope, very high power, but this device in particular is one that we think is actually can serve very well in low power applications. So while we are working with smart cities, and while we do see a lot of benefit from integrating our sensor within the power grids onto streetlights and getting all of that information available to anybody who's living in the area, we actually do serve a lot of benefit of seeing the sensor working in low power applications. We have the sensor able to work on its own, isolated in an empty field with a solar panel attached to it, and can be running and sending data to the user wherever they may be. So we feel that we can be really flexible depending on the power requirements of the solution.
And when you mention the word device, we're talking about sort of more prefab, pre-built, larger things which consist of several components, as opposed to an individual component like an integrated circuit. Or both.
What for the actual application themselves? I'm sorry.
So when we talk about devices that you guys are going to be manufacturing, and sort of deploying into these fields, are we talking more like products that have been made together from smaller parts? Or are we talking individual integrated circuits that you can buy, like for example, a pressure sensor chip or something like a light sensor?
Yeah, it's interesting that you bring up that as a question. I mean, our division of Omron is composed of several different divisions of our company focusing on different things. And up until recently, the basis of our division was electromechanical components, where we were selling power relay switches, connectors, and then sensors, a lot of our sensors being board level sensors that would be integrated into the larger part. It has been somewhat of a recent move for us, the weather sensor being our biggest example right now, of going into our new division title, which is Device and Module Solutions. So with us being able to now be producing and working on these more complete module sets, we're very excited. We're very excited to do that and have that more of a focus. So when we are talking about these field installations or even these streetlight applications, we have more or less standalone products. They're not integrated into the device itself, but they are integrated alongside them.
And I kind of wonder that in terms of the whole engineering sort of the engineering process of building these things, it must be quite easy when you've got your own in-house components, which you yourself manufacture, which you then put into your own product.
Yeah, we have a lot of we definitely have a lot of the experience working with these products, and it definitely serves a lot of benefit having, we have gotten all of these different components that we've made over the years, and being able to sit with them for a long time and working with them so many years, you think, well, having a lot of times when we were working with this component, we are also working with this component. A lot of times when people are looking for, sunlight sensing, they're also looking for rainfall sensing, or obviously when we're looking at climate solutions. So, actually, the original idea for the weather sensor came from, in part, one of the products that we were releasing was an IoT chipset that would be able to connect a lot of various different sensors to it, gather all that data, and be able to send it as one package to the user. And as we were thinking of different ways that we would be able to incorporate this device into whatever sort of application, one of the natural thought processes of it was for climate sensing. What area or what application you'd be looking for a lot of different sort of sensing properties. And we had a sensor at the time that was doing like room sensing for VOCs, temperature, humidity, that sort of thing. And getting something that would work outdoor and having our own chipset sort of be the basis for that part, that sort of built up this idea and made it into the product that we have today.
Now, when you mention about weather stations, for example, this is going to be kind of an ignorant question because I don't really know much in terms of like localized weather data gathering and stuff, because obviously I get my weather from the news. But what I'm kind of curious about is, why is it that businesses and customers are deploying so many of these sensors in such vast areas of sort of land and cities and farms? Because what I don't quite understand is how that data is used when weather is such a global and large sort of system.
I think it's a really interesting question because, we kind of think about that. I've been seeing in these projects where I'm installing some of these sensors, and I've thought about that myself. What is
the benefit
it really telling you having each of these here when we can just look that up? Well, I mean, obviously, for one thing, that weather data that we're getting is also coming from different sensors that are deployed. It's obviously coming from somewhere. But there are two big things that we see there when it comes to both smart city applications and when it comes to agriculture applications. For city applications, we're speaking with one major city in the U.S. that the entire scope of the city covers such a what's the word I'm looking for? Such a variable land space that it actually has 5 different microclimates within the city.
Blimey! Wow!
Having all of these, they're a coastal city. So they have the coast, they're getting up in the hills in some areas, they have sort of a desert area down in their valley. So they have a lot of different areas that need to be measured. And for a city like that to have all of these different weather sensors that are in their grid and being able to link to them, they have a way to access in each area of the city exactly what is the climate they're experiencing. And what measures might we need to do to take care of any issues that may arise.
And then from an engineering point, that actually kind of makes sense, especially for cities, because if you're building a very tall structure, you're going to have to consider thermal challenges, wind shear and all that kind of stuff. And that might be highly localized, like you said. So if you've got a lot of tall buildings, you're going to have really strong wind shears in different directions. And so if you build a new building, you want to go, I need to know exactly what these winds are doing for this very specific area.
Yeah, we're actually working with a company that specializes a lot in that sustainable construction, and they're doing that exact thing where they are measuring the wind patterns and seeing how they're affected by different buildings and what buildings might be experiencing. So they do a lot of work near airports. They do a lot of work near and large office buildings as well. And then the other thing I wanted to bring up is we see a lot of very interesting things with agriculture, but agriculture can be very sensitive for different crops with the type of climate that they're experiencing. You have, again, if you have these fields, especially in the middle part of the United States, but also around on the West Coast, you have these large acreages of farms that, one half of it might be experiencing a little bit of rainfall, and the other half might not have gotten.
I was literally about to say, I thought that was going to be a stupid question to ask, which was like, can a farm be so big that half of it's actually raining, the other half's not? But as you mentioned yourself, it can be.
Yeah, absolutely. It's interesting. Crop sciences, what they've done is that there is so much that is done, measuring the soil activity in different corners of a farm area and seeing, and being able to even modify crops that are or specialize in certain crops, like these are going to grow better in this area because you have a little bit more moisture in the soil, you have a little bit more rainfall that has been accumulating in this area. And we've certainly seen that, and how crops, a lot of crops can be very affected by that. Some like wheat, some like corn, they can be a little bit more flexible in the climates that they're in. But if you get into specialty crops, if you get into fruits, if you get into grapes, if you drink a little bit of wine, I mean, such a variability in what type of crop is produced, from wind shifts, from rain shifts, from the amount of sunlight that they're getting. So it's very interesting how important that microclimate data is, even though, as you said, we have almost anyone can open their phone and look at the weather all around the world. But getting that exactly how much rainfall has this area gotten, exactly what is the wind pattern that this area is experiencing.
And this is where it ties into the smart side, where if you're a farmer and you've got, let's say, irrigation systems, you might say switch off this half, conserve the water, put it on this half that hasn't received any rain, and then you're effectively balancing out where you're using your water, you're reducing water usage, and what you've done is taken that weather data and made it intelligent.
Exactly. Yeah, you couldn't have said it better. Honestly, that is one of the main applications when we've been getting into agriculture applications. That's one of the main ones that we see a lot, that we have conversations about, is linking in with those irrigation systems.
Now, I'm kind of curious about one thing, which is the challenges that you as a company have faced going into these sort of smart city, smart agricultural spaces, because it's an emerging field. It's not particularly it's not old. I mean, because internet technology has been around for 20, 30, 40 years now, but it's only really been recently that we've really tried to sort of maximize the amount of data we get from these spaces. So I'm kind of curious, as a company, what has been the biggest challenge trying to get into those markets?
It does sort of depend on the market. I think, I can answer for agriculture very easily. I think the biggest challenge is, honestly, there is so much in terms of tradition isn't necessarily the right word, but with agriculture, it's been very.
They do things in a certain way for the past 500 years, and they don't particularly want to change. Yeah. So it can be very, very resistant.
Finding that change it can be very difficult. I talk with some agriculture companies, and some of the guys that are there are, really interested in these sensors. But when it gets to the decision makers, it's a lot of difficulty making such a drastic change from ways you've done it for years and years and years to something that's automated, and something that's using this new piece of technology.
I wonder if companies like, probably can't mention the company name, but everybody knows who they are. But they're very dear to me. But do you reckon that companies like that who have historically had a bit of a, what's the word? They tend to have a bit of a rough relationship with the farmers in terms of like their access to technology, the equipment, the ability to repair it. Do you think these kinds of experiences with new technologies as they come in has kind of put them off from trying to adopt new measures?
So I've spoken with a lot of the larger companies such as that, and talking about these new types of sensors. I think as a whole, there is a desire for these companies to sort of integrate smarter technology and make it something that is, the next generation of product. This product has improved because of this and that. It is in some ways, though, you feel it, you see their product line. It almost seems like sort of a side show. Like they're trying out these new automated irrigation technologies, automated machine running technologies, using these different sensors. I don't think they're put off by it, but I do know that there is a sort of universal experience of this frustration in a way, but like the stagnation of the industry to sort of grow. I don't think it is for lack of trying. I think a lot of companies such as ourselves, such as the companies that are dear to us, I don't think they're discouraged. I think certainly as technology continues to evolve, and as the workforce continues to evolve, we're going to just continue seeing that more and more until eventually we start to see things tip.
And I think it's going to be a case as well of really giving farmers and other people in that field solid data to show what they can do, how they can improve things, why it's actually worth doing the transition. And so, and I'm guessing it might be one of those things where it won't be this generation, it'll be the next. And so you have to sort of, do you know what, there are so many puns in this podcast, I swear to God, honestly. Because I was about to say, this is where you sow the seeds for the next generation. But in effect, it's what you're doing. You're creating the technology, you're proving it's working, you're getting it out there, but it will be the next generation that actually reaps the rewards.
Yeah, and that very well may be that's how it works out. And in my opinion, is if we're getting something that makes that agriculture sector or the smart city sector easier, safer, more efficient, I think that's still a win. Even if it isn't going to be the people that are here and now experiencing and getting to reap the benefits of it. But I do get encouraged by how continuously we are still wanting to integrate different technology. I think there is coming into generationally. I think there's almost in some ways like technology is getting too far in one direction, and people want to sort of adapt more of the analog structure and keep different pieces of technology out, but having these basic sensors, having these basic sensor functionality, and that's one thing that we sort of really talk about or really have with our products at Omron, is having these sensors that are, while very new technology, all this new information coming in, new integration. At its core, it's a very simple sensor. It's a digital thermometer, it's a digital wind reader, it's a digital rainfall meter, all of this in one, being able to transmit that data. It's not anything that is, at least I feel, taking things away.
Yeah.
We've been working with farmers on this sort of technology, if we're sticking with the agriculture industry, but working with farmers, like putting it into their fields and seeing how it's tested out. We've seen the benefits that it can really bring. It's interesting in some respects how some technology can be slower to incorporate.
And so you would say that your biggest resistance, the biggest challenge that you've seen, is that there are industries, there are customers, there are people who do things in a certain way, and trying to demonstrate to them the benefits of the new technology can be quite hard because some people can be quite stuck in the way they do things.
Yeah. That's certainly one of the big challenges that we see. I mean, that's especially particular around the agriculture industry. And another challenge that we found that's been very interesting, and one that we've gotten a lot of education on as well, is the various different types of communication that people are looking for. Especially when it comes to digital information sharing. There are so many different ways of wireless communication, and we have cellular networks that are very common. Wi-Fi, Bluetooth is ones that are more like common for consumer grade, but there are very different communication platforms that are becoming available. LoRa, LoRaWAN are two that we've seen a lot of. That we've partnered up with some companies. We've partnered up with a company called KST to help us get into incorporate our weather sensor onto LoRa networks. But we see there is also kind of that challenge of managing that data. At our core, we are a components provider. We have our sensors, switches, connectors, relays, all of that. We've found a lot of challenge in, when users are looking for our products, typically our history has been, here's your relay.
Go do what you want with it effectively,
and you're good to go. But when it comes with like sensors, it's like, here's your sensor. And they're like, well, how are we going to communicate?
Yeah.
How are we going to get this data? How can we read this data? That's something that we have needed to learn a lot more about, because there's a lot more involved that comes with sensing technology. It's not just, here's your thermal sensor. It's just like, okay, great, here it is. how do I know what temperature it's getting?
It's effectively moving in from the hardware domain to the software domain and the user interface domain, and it brings in a lot of ugliness that you would normally not have to deal with. And you'd be like, "Oh, right, I've got to figure out how to make all this work together in one big package."
Right. And we've been working well with our a lot of the customers that we've been working with. Thankfully, also have had a lot of their own resources and been able to pull that data. And we're able to send simple CSV file packages for our weather sensor, for example. But being able to work with open up to some other companies that have a little bit more of this experience, such as KST. And being able to get a little bit more insight into how to better integrate these sensors, how to pull this data, and how to really make this something that is usable for the consumer.
And also finding partners who you can rely on that can provide good services.
Yeah, absolutely. Finding partners is definitely a challenge, almost if not more difficult than finding a reliable customer. So yeah, we've been very proud at Omron as a lot of our products, a lot of our development have all fully happened in-house, and coming into this sensing technology and very advanced devices and modules, we've started to learn how to really reach out and ask for a little help when we want to kind of keep pace with the growing industry.
So just before we wrap up this podcast, I've got two more questions. The first one's a bit of a bigger one. The second one's a very simple one. So the first one, we've talked about smart agriculture. We've talked about smart spaces. We've talked about smart cities. Besides those two, what do you think could be the next sort of big area or big market that might open up to smart technologies that you think that Omron might be kind of looking to sort of snipe?
Oh, I think that's a really good question.
Because if you answer it, your competitors will know where you're going.
That's true. We don't necessarily want to.
We're not going to answer the question.
We don't want to show all of our cards. I do find it interesting. When we first developed the weather sensor, I think one of our no-brainer applications and who we first started working with were agriculture companies, because obviously they're going to be looking for those climate solutions. And it's been, as we've worked with it, and as we've, we go to shows and we have it, we get approached by these customers that, we didn't know that would be something that would be useful, but, obviously thinking a little bit more, of course. Working in the smart street lighting, the smart city applications, I found it very interesting when we were working with the company that's working in sustainable construction. So that was something that I found was very interesting. But I think we have seen a lot of very interesting applications of how weather tracking is working within certain utilities. We look at energy management and
renewables, for example.
What's that?
Renewable energy would be a big one, I imagine.
Renewable energy, yeah, absolutely. Renewable energy, solar farms, wind farms. They're obviously very affected by the wind patterns and the solar patterns, but even water management, we've been learning recently there is a lot of ways that it can be affected by rainfall, temperature, wind speed, wind direction, wastewater management, water treatment facilities. We've been seeing a lot of very interesting development in how sensing data can really affect it. Not just, how clean is the water, how much water flow are they getting, but the water sources can really be affected by the weather conditions, and how.
Well, that comes back into the agriculture side, where if you've got runoff from farms, they've just done a bunch of spraying that goes into the runoff, goes into the lake, goes into the sea, wherever it's going. That would be one of those things you want to pick up on.
Yeah, absolutely. It's very interesting as you kind of follow that breadcrumb trail, and you're doing very well at following it yourself. But you get into one application and you find the source of it, and you're just like, oh well, actually we can take that and move everything up the line. or down the line of what's being affected. You know, you take the crops, you have them grown on the farm, and then you see how the sensor is going to be working beyond that, like where the crops are going at stores through shipping processes. So it is very interesting how things kind of build, and it's almost when you kind of get carried away on a home improvement project.
Yeah,
where
just keeps going.
Right. You go into the bathroom and you're like, oh, you know, it'd be really cool to upgrade this sink. And once you do that, you're just like, man,
everything just looks wrong. Everything's got to be all redone. I know the feeling. I absolutely know the feeling. Do you know, there's one thing I actually wanted to mention very quickly about when you mentioned about like rainfall across different farms and, you know, across the same farm, different areas and stuff. I was almost thinking, if you're looking at it from the renewable energy side of things, imagine if you had a very large solar farm and you want to try and maximize the energy out of this thing. I can imagine in the future they might have these types of smart sensors where they can almost predict the wind direction and where cloud shadows will be, to the point where they'll be casted on certain panels and you could potentially switch those off so the other ones are operating while those ones aren't. So you maximize the power from the system. But I don't know if that would be something, but I can imagine something like that where you almost like model the actual planet itself, or certainly further out than you normally would, so you can maximize areas of energy gain.
I mean, Robin, on a smaller scale, that's already being talked about for how different solar panels are going to be affected by different weather patterns. So yeah, that's a really big goal for renewable energies is the best ways to capture that data, or to capture the energy from the sun, and the best way to manage that. So yeah.
Absolutely fantastic. Now, my final question before we wrap up this podcast, and it's just the last one. For those who are watching this video, if they want to get involved with the solutions that you guys have been producing, what would you recommend that they do?
We of course have our website at components.omron.com. We are a global company, so while we are based in Japan, we have representatives and offices all over the world. So no matter where you are, I'm sure we have somebody that is able to connect with you, that is local and able to hook you up with any sort of sensing devices, product advice that you need for integration. So please, I encourage you to reach out. And of course, if you have any questions directly about the weather sensor, you can obviously reach out to me directly. I don't know if my contact information is going to be featured on the podcast or anything like that, but
it will be now. Fantastic. Well, all I can say is thank you ever so much for taking the time to see us today.
Thank you very much, Robin.
Thank you.